Welcome, students, to your next class of polynomials, because most of your classmates are facing difficulties in understanding polynomials. That's why I am taking more classes on polynomials. Let us start with remainder theorem. You know, if Px is a polynomial, okay, and x minus 1 is a factor given, then what value of Px will be 0, P1 will be 0, okay. If x plus 2 is a factor, then which Px value will be 0, P minus 2 will be 0. Do you know? Or you have forgotten this one? If Px is a polynomial, having any type of polynomial, and it is given that x minus 1 is a factor, then x minus 1, write the factor, x minus 1 with some 0 equal to 0, and you will get the value of x. Okay, that's why I have written x. Similarly, if x plus 2 is a factor, then write in this way, and you will get the value of x, p minus 2 is 0. Okay, so this will be needed in this class. That's why I am telling you. So let's factorize first. 6x square plus 5x minus 6. 6x square minus 5x plus 6. Factorization. Prime factorization. Okay. So how to proceed? Split minus 5 in such a way that the sum will be minus 5 and the product will be 36. Product will be the a and c. This is the form of ax square plus bx plus c, or quadratic polynomial. Okay. So the product is b, the sum is b and the product is ac. The sum will be b and the product will be ac. A into c. Okay. So what is value of a? 6. And what is value of c? 6. So ac is 6 into 6, 36. So product will be 36 and sum will be minus 5. So split minus 5 in such a way that the product will be minus 36. Okay. So otherwise split 36 in such a way that the sum will be minus 5. The same thing. Okay. So how do 2, 12 cannot be minus 5? Because there is no relation, no gap of 2, 12 to get minus 5. 3, 2, 12, sorry, 3, 12. 3, 12, it cannot be made 5 minus 5. 4, 9. See, here 5 can be made out. We can, because the difference is 5, so you have to calculate minus 5. You have to split minus 5 as minus 9 plus 4. Minus 36. 6x square plus 5x minus 6. Sorry, plus 5x minus 6. Okay, so the question was wrong. See the corrected question. The product will be minus 36 and the sum will be plus 5. Okay, product will be minus 36 and sum will be plus 5. So we will take 4, 9 because the difference must be plus 5. So how to take? The product is a negative value and you have to get 4, 9, then minus 4 plus 9 or plus 4 minus 9. Two cases are there, two possibilities are there. So we have to got sum as plus 5. So I will take this one to get plus 5. in both the cases minus 36 are coming, but the sum must be plus 5, so I will take this one, plus 9 minus 5, no, minus 4, plus 9 minus 4. Okay, so let's split. So always take some rough space to solve this one. Don't do haphazardly. 6x square plus 9x minus 4x minus 6. Okay, now we can proceed. So these things is important. How to take 5x into 2 form plus minus. Okay, now take common from these two. What will be the common? 2 into 3 into x into x. This is 3 into 3 into x minus 2 into 2 into x minus 2 into 3. Okay, now take this one. 3 is common, x is common. So 3x will be common. 3x will be common. The remaining is 2x here. Remaining is 3 here. Now take from these two. 2 is common. Okay. If 2 is common, what will be the remaining here? 2x. Here remaining is 3. Okay, plus 3. Because minus is taking common here. If minus is taking common, after taking minus common, it will be plus. Okay. So from these two part, what will be common? 2x plus 3 is common, like 2x plus 3. After taking 2x plus 3, what will be the remaining? 3x. What will be the remaining here? Minus 2. Okay, this is the factorization. Okay, the not so easy, either simple one. Something we have to think over here for a more time. Okay, so let's go another example. Explain whether x plus 1 is a factor. Examine whether x plus 1, the pen is not running, x plus 1 is a factor of x cube plus x square plus x plus 1. Polynomial. It is a polynomial. So the question is like this. Examine whether x plus 1 is a factor of this without long division. Okay, how to check? If I have already told from the beginning of this class that if x plus 1 is a factor, then suppose px, take this example, take this polynomial as px. You can take it fx, gx, px, gx, like this. If px is the polynomial for this, if x plus 1 is a factor, then p minus 1 will be 0. If p minus 1 is 0, if according to remainder theorem, if x plus 1 is a factor, then p minus 1 will be 0. Okay, so let's check whether p minus 1 will be 0 or not. So take p minus 1, minus 1 whole cube. This is also not running properly. Okay, minus 1 whole cube, again minus 1 whole square, again minus 1, again plus 1. I have just put the value of x as minus 1, nothing else. So minus 1 whole cube, who can say? The odd power of minus 1 is always minus 1. Even power is always plus 1. And plus minus minus 1 plus 1. Minus 1 plus 1 minus 1 plus 1. 0. So it is a factor. Okay. So I can write here, hence x plus 1 is a factor of this polynomial. If this does not come with 0 as a result, this will not be a factor. Okay? Let's go some different type of example regarding polynomial. Let's take another example, something different. Find the value of x if x plus 1 is a factor of this. Question. Find x if x minus 1 is a factor, x minus 1 is a factor of polynomial x square plus x plus k, x square plus x plus k. Okay. Find x or find k. Find the k, find the value of k, not x. Find k if x minus 1 is a factor of this. This is a polynomial. Okay. So the for this polynomial, this is a factor x minus 1. So find the value of k. We know that for the remainder theorem, if this is a factor of this px, then suppose let's write the polynomial as denoted as px. Okay. If x minus 1 is a factor, then what value of p will be 0? P1. If x minus 1 is a factor, P1 is 0. Because how to calculate? Take x minus 1 as 0 and x will be 1. So P1. So P1 will be 0. That means P1, right? One value, 1 square plus 1 plus k is 0. I am putting the value of x as 1. Okay. So 1 square is 1. 1 plus 1, 2 plus k equal to 0. That means k equal to this 2 will be changing side, it will be minus 2. So this is the value of k. Find k, the value of k is minus 2. Okay, could you follow this one? Or shall we go with another example like this? I think we should go for another example. Let's go. Kx square minus root 2x plus 1. Kx square plus root 2x minus 1. Let me see the question once more. Kx square plus kx square minus root 2x plus 1. Kx square minus root 2x plus 1. Minus root 2x plus 1. Okay. So the same thing is there. The polynomial is different here. The question is same. Find the value of k if x minus 1 is a factor of this one. Let's this denoted the polynomial as px. X minus 1 is a factor means p1 is 0. That means at the value of p1, what is p1? K into 1 square minus root 2 into 1 plus 1 equal to 0. Okay. K into 1 square k minus root 2 plus 1 equal to 0. So what will be the k? Take this one, it will be positive here, root 2, take this one, this will be negative here. So k is the root 2 minus 1. This is the answer. Okay. Okay. So these are all the things remaining regarding your polynomials. We'll discuss the whole chapter in a single class in our next video. Thank you.